Okay, pressing on. This is our last video. Thank ya. It's been quite a bit of effort on my part to put these together. Okay, last one is to have, if we add a weak acid with a strong base. The other one would be if you had a strong acid and a weak base, which is a similar idea. I'm just going to go through this one. We're never going to go through weak acid and weak base because that's beyond the scope of this class. It's always great to say that. Okay, weak acid and strong base. This is, I'm going over example problem 17.4 in your book, okay? So we're taking acetic acid, CH3COOH, and we are adding some sodium hydroxide. And we're going to look at 3 different scenarios, as in 3 different amounts of each thing that we're adding. It's the same sort of thing, even though, you know, this, we don't think about it partially dissociating. Yet. But we look at this as, okay, so it forms the salt, which is CH3COONA plus water. So scenario 1, we are adding first 10 milliliters of sodium hydroxide, and the concentration of that is 0.1 molar, and we're adding 25 milliliters of acid, and the concentration of that is also 0.1 molar. So we need to figure out the number of moles that this means, or what this is. So number of moles of acetic acid is equal to, same way, take 25 milliliters and for the sake of this example, oh no, I can leave this. Okay, we're good. Let me just move things over a little bit. Figuring out the number of moles of acetic acid, CH3COOH, that's 25 over 1,000 we got this from 1 molar, so then we get this to be 2.5 times 10 to the minus 3 moles of acetic acid. For the number of moles, let me move this up. We have 10 milliliters, 1,000, and we get 1 times 10 to the minus 3 moles. So we're going to set up a similar ice table like we did before. So let's just look at one side of it because we don't care about what we're producing here. What we care about is we want to know the pH of the solution after we add these together. Okay? So, and the pH is going to come from whatever's left over of acid, or whatever left over from base, or if it's totally neutralized. Alright, good. So in this case, we're going to have excess acid. So we start with CH3COOH plus NaOH. That goes to products. Initially, we start with 2.5 times 10 to the minus 3 moles and 1.0 times 10 to the minus 3 moles. all of the sodium hydroxide is going to be consumed here. We can assume that. So then, here's our change. And then we end up with 1.5 times 10 to the minus 3 moles of acetic acid, and we have 0 of the sodium hydroxide. So this is what's left over. Now remember, acetic acid is a weak acid, so we can't just write, when we write over here, CH3COOH going to, it's partially dissociating to H plus and CH3COO minus, right? Let me dab away. It's only partially dissociating. So if we're starting with 0, we're going to take a shortcut. Okay, it's partially dissociating, right? So, and it's a weak acid, it has a pKa value, or it has a Ka value of 4.5. We know this by heart, times 10 to the minus 4 after doing our problem set, right? So, when we write the expression for Ka, it's going to be H plus products, CH3COO minus, over the reactants, CH3COOH. And what we need to do, because we want to solve for H plus, is we can rearrange this so that we can solve for H plus. What do I mean? We end up saying H plus is equal to, so if we divide, if we do the algebra, okay, this is the doing the algebra part. I'm not going to show it because we don't have a lot of space, but if we did the algebra, we would see that H plus is equal to Ka times, and I have to actually look, make sure I got this right. Yeah. We end up with Ka times CH3COOH all over conjugate base concentration. So we have those values. Now, from there, we have the concentration, or at least we have the number of moles of acid that has been left over. Oh, I know what I need to do. Okay, hold on a second. Okay, all right, we don't need that value. It ends up being, for the concentration of acetic acid, it's 1.5 times 10 to the minus 3. For the concentration of conjugate base, it's 1.0 times 10 to the minus 3. And for the Ka of acetic acid, they're saying it's 1.8 times 10 to the minus 5. So I got to figure that out. So we're going to put a pause. We're going to come back. To be continued.